Are we good? All right. And we are on time. We almost made it. Thank you very much for joining. I'm Devang from Microsoft, part of the Fabric Customer Advisory team. And today we're going to talk about the what and the why of Fabric real-time analytics. I see some familiar faces in the crowd who have been in the session, so good to see those faces back. Always gives the speaker a little bit of sense of confidence that, yes, people are interested in listening. Um, so I'm going to talk a little bit with slides about what is Fabric real-time analytics, why, what are the use cases that would be applicable, and then we'll go into some interesting demos. Okay, we're going to also have an interactive demo, so be prepared for it. But we'll go through it when we get there. Just a little bit of a backstory: my USB-C port stopped working just now. So we had to, Luke kindly was in the room and he volunteered his laptop. So now we are doing Teams sharing, and that's how we are seeing the slides. So technology works sometimes. All right. So first of all, your feedback matters. So if you want to scan the QR code and keep it on your phones, and would love to know what you think about the session, and also whatever feedback you provide. There's also contribution that goes to charities, so that's always helpful. Moving forward, so why real-time analytics? So what we are going to focus on and why Microsoft has built real-time analytics into Fabric is focusing on high granularity data. Data which is generated continuously from variety of different assets, variety of different digital or physical assets. You want to capture that data raw, and you want to turn those insights into a competitive advantage for your organizations. So that is why Microsoft has decided to include real-time analytics in Fabric. So that's really the purpose of doing this real-time analytics. Now, this is also very conceptual, but let's turn this into something with an example. So since now we are at Fabric, in SQL Bits with aviation theme, so here is an example of what are the scenarios in the aviation space. So number one, you have an aircraft. Aircraft has a lot of time series interesting data, right? Aircraft has a number of different sensors which are continuously emitting what is my status, what is my values of the different sensors at every time stamp, whether it's every second, every millisecond, every minute, depending on how the sensor has been configured, airline is continuously emitting that data. Second, aircraft is also kind of a time-dependent graph. So because aircraft is also a hierarchy of different components. There's an aircraft has an engine has different components. Or aircraft has doors has windows, or the whole the pilot's cabin, all those with knobs and buttons. All of these are sensors, and these are also kind of graph. So if you can combine all the sensor data, the time series data with the graph data, you can get very interesting insights in terms of what was happening with the aircraft along a period of time, across different components and different hierarchies. So that is also what you can do with, this is also a scenario in the aviation space. Number three, generative AI. We are in this era where a lot of organizations want to build generative AI mobile apps. So if you want to build generative AI app in the aviation scenario, look at all the different customer feedback you are getting, and if you want to build chatbots for your own data, you can also do that. This is also a scenario where you need to capture a lot of data, generate vector embeddings, and you want to match those vector embeddings or search vector embeddings so you can develop some really cool Gen AI applications. So that's another scenario as well, which has this high granularity data, and you want to capture that. Number four, flight tracking. You may have seen some demos. There is one very cool demo which is playing on the big screen in SQL Bits, where there's a flight just moving around. That's very geospatial, right? You can do flight tracking on how flights are flying around different parts of the world, and if you wanted to do that. This is also very important for the aviation industry or airline companies or air traffic controllers. They want to track and see how the flights are moving around. Number five, events. Whether it's passenger journey or whether it's passenger's bags journey, right? Passenger books a ticket on an airline's website to the passenger coming to the airport, does a check-in, checks in its bags, goes to the boarding gate, takes the flight, arrives at the destination, again takes the bags, and walks off the airport, right? All these are interesting events for any airline company that they want to capture, and they want to analyze these events so that they can offer better customer experience to their travelers or to their passengers. This is also a lot of event type of data which is generated in the aviation industry. That was also something you want to capture. Again, very high granularity data because these events can occur every second, and if there are millions of passengers traveling across multiple airports, you're suddenly having a big volume of data that you would want to analyze. Last but not the least, in the aircraft airline industry, most of the organizations have cloud applications, on-prem applications, cloud databases, on-prem databases, Kubernetes clusters, data platforms. All these different digital assets generate tons and tons of logs. And all these logs also need to be captured, analyzed, stored, so that you can have some interesting insights. You can make sure that your cloud applications as well as on-prem applications are up, they are available, and your customers do not face any downtime. So for example, these are the 6 types of scenarios you can see in aviation industry where high granularity data, whether it's time series data, geospatial data, event data, vector data, this is all very, this is all data which is very interesting, and you want to be able to capture it, store it, analyze it. And this is what you can do with real-time analytics in Fabric. So this is an example from an aviation scenario. But this example is not limited to only aviation. You can do this across many different verticals, whether it's manufacturing, whether it's logistics, connected cars, connected trucks, connected vehicles, parcels, for DHL or FedEx or et cetera, or even Royal Mail, parcels moving around the whole country or whole city generates tons and tons of data, and you want to be sure that these parcels are reaching the destination on time. So this is, an example from logistics. Energy industry. If you look at wind turbines, solar panels, hydro plants, these are also generating tons and tons of telemetry data. What is my, if there is a wind turbine somewhere in the North Sea, which is generating power every second, this is the value which is continuously being, generated by the wind turbine. You want to be able to capture it, analyze it, so you can detect defects. You can do predictive maintenance on those wind turbines, on those energies. So these are the different scenarios across different verticals which are possible to unlock with the Fabric Real-Time Analytics. And these are the type of use cases we want to address with Microsoft Fabric Real-Time Analytics, and that is why Microsoft has decided to invest and build Fabric Real-Time Analytics. Now, going a little bit deeper, I gave you some examples of different verticals from manufacturing, energy, financial services, retail. You have some icons here which kind of gives you an indication what are the asset types that can generate this data. Data that is generated by these assets are typically telemetry data, time series data. That is what is being generated. But this data, as you saw in the aviation industry, is also coming from the digital world. Logs, metrics, traces, this is the type of data coming from the digital world. Now, both this type of data have some similarities. The similarities are this data is typically coming at high frequency, high volume, and high velocity. So we have examples of customers who want to emit and who transmit terabytes per day type of data. So this is the data that comes at very high frequency, and you want to be able to capture that. So any platform which wants to address these scenarios, unlock these scenarios, should be able to handle these type of characteristics. But it's not only limited to that. This data is typically semi-structured or free text as well. So logs, for example, have a lot of free text. Developers love to put interesting information in free text, so you want to be able to analyze that as well. But JSONs, XMLs, Parquets, these are very common formats that we see when the data is arriving from all these different, whether it's a digital world or the physical world. Typically, this data is immutable. So this is the data that typically you don't go and update or you don't go and change values because that's, whatever, for example, if the wind turbine has said this is the amount of power I generated at 12 noon, then that's it, right? You don't go and update that value. So this data is typically immutable in nature as well. This data needs to be analyzed at low latency because whenever this, for example, if wind turbine is reporting that I'm not generating enough power, you have some values which are being reported, you want to analyze those values close to the generation time because that's where the data has very high value. As the data gets old or as the data gets stale, the value decreases. That data is only becoming relevant for trend analysis or historical analysis. But if you want to take any action in order to mitigate some defects in your asset, you want to take that action close to the real time or close to when the data was generated. And last but not the least, this data is also known for schema drift. So data that is, For example, there is a firmware upgrade on the asset, and it adds a new column, or it adds a new field, and you want to be able to handle handle those additional fields or new columns as well in your data model or in your data platform. Otherwise, your pipelines will break or your dashboards won't refresh. So this is a typical characteristics that you see, whether it's data coming from physical world or whether it's data coming from digital worlds, whether it's time series data or logs data. These are typical characteristics, and this is what we are trying to address with Fabric real-time analytics. Now, you may have already seen this picture multiple times, I believe, about Microsoft Fabric and what it stands for. We are going to focus on Synapse Real-Time Analytics, Power BI, and Data Activator. So this is where we are going to go with our demo. This is where we are going to spend more time in terms of what this is and what can you do with it. Now, just to create a mapping, if some of you are familiar with Azure, has anyone worked with Azure Data Explorer or Event Hub or Stream Analytics? Any of the services? Maybe a show of hands. Great. So these are the Azure services: Data Explorer, Event Hub, and Stream Analytics. These services become available in Fabric as KQL database or Event House, and I'll get to that in a bit. So Data Explorer becomes KQL database, Event House in Fabric, and Event Hub and Stream Analytics have been combined or refactored into a one single service as Event Stream. This is how it shows up in Fabric as a platform. On top of KQL database and Event Stream, you also have KQL query set, which is more like a notebook experience for you to write queries and interact with the data that you bring into a KQL database. And another additional service, which is not present in Azure, but has been included in Fabric, is Data Activator, which allows you to go from insights into actions and alerts. So this is what you can do with Data Activator. So this is just to create a mapping for people who are familiar with what is happening in Microsoft Azure and how that translates into what you can do with Microsoft Fabric. Okay? Any questions at this stage before we move forward? No? Quiet crowd? Okay. But we'll get you going. So again, just to put like a architecture picture in front of you, you can have a variety of different sources of data. You push that into Event Stream. So Event Stream is like the streaming service where you can push data and works like a pub/sub mechanism. You can push data into it, and then a KQL database will read data from Event Stream, store it, and then you can build all type of interesting alerts, actions, dashboards, insights on that data. So this is what you can do in terms of overall pattern, what you can do with real-time analytics. Okay? Now with this, we are going to switch to a demo. All right, so what we're going to do is I have a little event stream. So what we've done here is we have a little mobile application. It's a web browser application, which captures noise from this room. Okay? So this particular mobile application is going to publish data to this event stream. Right? So what I've done here is I have created a little application source where I'm publishing data to this Event Hub. And I get, for example, here, if you look at this, you get an Event Hub endpoint. This is the endpoint I have supplied to my application, and my application is sending JSON data to this particular event stream. Okay, so this is the first thing I have done. In event stream, you have multiple sources. You can have some sample data. So if you don't have any data to play with, and if you want to just start with real-time analytics, you can use any of these pre-canned data sets that we provide, and you can build your own experience. But if you want to try some application, you can do this as well. So here I have chosen Custom App as a source, and then Custom App, we support 3 endpoints, Event Hub, AMQP, and Kafka, and you can publish your data to these particular endpoints, depending on the protocol with which you want to work. We also provide some sample code in case you directly want to include that in your application. Right now it's Java, but we will have support for multiple different languages in the coming releases. Okay? Now, if I look at my event stream, this is a type of sample data I'm getting. Okay? So every second, I'm getting a bunch of values, which are in an array. Okay? Just to zoom in. So as you can see, I have a timestamp and a bunch of different values in an array. Now, I want to capture this data into a KQL database. So this is what I'm choosing as a destination. So if you choose or if you go to new destination, you typically have 4 options. You can again have a custom application, so you can push data out to another set of endpoints, or you can store data in a lakehouse as a delta tables, or you can push data into a KQL database, or you can start setting up alerts and triggers on Reflex as a data activator item, right? So these are the 4 options you have. So here in this particular demo, I have chosen KQL database as a destination. So now, for example, if I go to this particular KQL database, you see there is a little option here, which is called Event Processing Editor. As you saw, my event stream has this array of JSON values, right? Now, this array of JSON values are not very interesting. I want to expand those arrays and capture every value so that I can start working with that data. So this is what I'm doing. I'm choosing an expand operation. So right now, we support these operations: aggregation, expand, filter, group by. So I'm choosing expand as an operation, which will expand all my JSON arrays into individual values so they become rows. So then I can work with it, and I can make some interesting visuals out of it. So as you could see, all those arrays of values now become individual rows in my data, okay? And this is the data I'm now storing in my KQL database. So far, everyone with me? Good to go? All right. So we have an application which is pushing data into event stream. We've done some transformation of data. Now we have the data in the format we want. So we'll store it we are storing that in the KQL database. So now let's switch to the KQL database. So if I go to Power Hour demo, I was trying to do this demo yesterday, did not really work out. So I see some faces and smiles in the back like, yeah, we know that one. That was supposed to work, but did not work. But now we're going to make it work right now. So, but I'll need your help for that, so just to be clear. So here I have multiple tables. For example, I'm putting this data into raw noise table. So you'll see, for example, if I do raw noise table, take 10. What you see on the screen is KQL, or Kusto Query Language. That's the language which is used in real-time analytics to interact with your data stored in KQL database. Has anyone written Kusto Query Language in Log Analytics, Azure Monitor? The Microsoft guys, I of course know. OK, very few hands, but OK, that's good. You have something to learn, and you have something to go away and work with. So this is what you do with Kusto Query Language. You typically start with the table name, and you start building different filters, clauses in order to derive your data. So it works like a funnel. You start with table, which is the highest level, and then you start applying different filters till the point you reach the insights that you want to take out of your data. So here, as you see, whatever you saw in the event stream, the same data is available here in your KQL database. Now, what you can do with this KQL database, for example, you can just simply choose the name of the table and click on Build Power BI Report. And it will start, it will just basically what it will do is create a direct query connection between Power BI and KQL dataset, okay? So between Power BI and KQL database, it's a direct query which works, and it works very well. It's according to me and some of my colleagues, but let's say according to me, it's the best direct query implementation in the world with any data source. It works, and it works really well. It works really fast, and you will see it. So I don't have to sell it to you. Now, so here you can create multiple different types of visuals because your table is already available here as different columns, and you can build an interesting visual here. But we are going to, for example, you can also do the same with Power BI Desktop. So let's open Power BI Desktop, which should not take too long. All right, so let's create a new report. If you go to new report, I should sign in, of course. All right, so when you're in Power BI Desktop, you can simply